Okay, so to go to the metrology lab, you go to the elevators, you press lower levels, level number 2. Jump to the elevator before it's going to close the door. Wait here, don't press anything. Okay, that's took a long time. Yep. And we're going down to level 2.
Level 2.
So as you leave the level, don't go this way, go the other way. So that way is the correct way to the metrology lab. Now you can see that we have a sign here telling you what are the labs available in level number 2. The metrology lab is the second from the bottom. You turn to the left, you go all the way down. Just in case, if you are going to the washroom is going to be here for the gentleman's room, and I think that the ladies' room is going to be, yeah, this room here. So anyway, so you will see these machines. You turn to the right. This is the emergency stairs. You go one level down. So I came from this door and going down to here. Yeah, the students for the metrology lab cannot find their way. Yeah. So we're taking the first door to the right. The first corridor to the right. So it's not the first door. This is actually utility door. Now the second. This is the art store. And the third door to your right. The door would be maroon color. Okay. So mostly me or yeah. So this metrology lab. This go for it. Okay. Me or one of the staff is going to be here. When I'm going to be inside, I'm going to let me hold it over the other hand to get my card. Sorry. Okay, so get my card. I am one of the few people who have the access to here. Okay. So we get inside. Usually you're going to find Jing, which is the lab manager. She's going to be in this room. But however, I'll try to keep the door open as long as it's going to be here. Obviously, it's not here at the moment. Okay, so let's look around. That's what we're going to cover today. I'm not going to talk about these simple devices like the vernier or the micrometers, but we are going to use the gauge blocks. So I told you about this one yesterday in the lecture. We're going to use these gauge blocks to build a specific height to do the calibration for the height gauge, which is going to be, I don't know how to look, I never know how to look. Okay, which will be this one. So I'm going to learn how to use this machine tomorrow. I'm going to be with you, and for the morning session Junaid is going to be with you, and for the afternoon session Amanda is going to be with you. And I'm going to be here anyway all the time. So with this video, I'm going to send you the videos which are going to show you how to use these machines. The process, I can repeat this process very fast here. So turn on the machine. Seems that the battery is dead. Yeah, I can tell that the battery is dead. However, it's uploading the system, and then we are going to be able to use the device. So I think that you used this one earlier. So here tell you to take this lever up all the way. So I'm going to take it up until I'm going to hear the beep. Okay, then I'm going to take it down. You can see that this reading is going to read the approximate height of this probe. Okay, so take it down. It's going to touch the table. So it's telling you that when it's going to touch the table, when it's not calibrated, it's going to tell you that this height is 0.245 millimeters or 0.25 millimeters. So we need to do a process of the calibration, and usually I'm going to press this function. So if I'm going to press this function, just take it a little bit higher, and then press this function. Is going to ask you about how you are going to calibrate that. So obviously I'm going to use number 1, which is going to be the absolute. So everything is going to be considered from the height of the table. So this will be 0 level, and everything above is going to be reference to it. So press number 1, and then you can see that the device is coming down. It's telling you it's measuring. As touch the table, facing some resistance, set. So the set is going to be 0 here. Now what we are going to do tomorrow, and actually I can show you something like that. Well, I'm going to take one of these blocks, and I'm going to check this simple calibration process. So for example, you can see that these blocks tell you that the height is 2.2. I hope that you can see that, and this one is going to be 2.22. So I'm going to take this one, I'm going to put it on the table and check the accuracy of my device. Okay, so just remember that now I think this will not going to be enough by itself. So because this device is giving you the accuracy of 1/10 in thousandths of the millimeters. So the better thing is going to do is taking something in thousandths of millimeters. So this one have the, well, I hope that you can have a good construct. Yeah, yeah. So this one is 2 millimeters and 0.01 millimeter, 0.001. So it's going to be 1 in thousands of millimeters. So I'm going to take this specimen and try to do the calibration with it. Well, I don't expect that we're going to have the full accuracy for this machine, not because the machine is not accurate, but because the table has a problem, and we're going to talk about what the problem possible for this table. So I put it exactly under the probe, okay, and I'll try to measure the height of this one. So when we come to the machine, we see different functions. I'm going to check this one, which check the height of the surface from the reference. So pressing that, you'll see that it's going to do the measurement directly. So it's giving you that the height of this surface is 2.0047. 2.0047. We said that the height of this surface meant to be, and this is actually a very specific height. Let me find the height reading and show you the, yep. Where's the camera? Yeah. I need to make the focusing on that. Doesn't look good. Anyway, I'm going to read it, though I don't have my glasses, and that's very funny. Anyway, so the height, I think it was 2.001. Right, yeah, right. So I didn't double check that. So. Yeah, it is 2.001, but what we had here was 2.004. So we got actually quite high mistake in the 10th of a millimeter. So what I'm going to do is I'm going to move the specimen to the other side, and this will actually going to show something if the reading is going to be different as well. Okay, now it's always having the systematic error of 0.006 in the minus. So it's always going to, well, yeah, in the positive actually, it's always read 0.0055 value in addition. So we have to consider that in the calibration process. The calibration of this device actually is quite complicated. We need to go through all these functions, and to be honest, I'm not the expert with that, and I don't want to do something with the university tools that this may break up. I don't want to pay anything for them. Okay, so I hope I'm not was putting my hand there. Okay, so we can check that manually. So the height, so as you can see, we're always going to have the error. Now I'm pressing on the probe downward. So, yeah, so this machine is not 100% accurate. The reason for that maybe is going to be the table levelness, or maybe some particles put in here. So what I'm going to do is I'm going to try to move the machine to another position. Tell me that the battery dropped because we use the air cushion, and I'm going to check the height on this position. Hopefully it's going to make some differences. Just remember that I actually need to calibrate the machine earlier. Okay. Okay, now you can see that the error has been dropped. Now we're reading 2.0035. So actually this is good indication that's actually what's happening is not the machine itself, but the table actually having some error. And we need to take something about 5 readings on average and fill the table attached to your work, and then we are going to be able, yep, well, in this position is tell me exactly that the height is 2.001, and this is the actual height. So just remember that I'm putting the machine in this position that gave me the accurate value, but let's check. Yeah, and it's reading 0. So I'm going to repeat the process of doing the calibration of the absolute to this level, and then I'm going to, this is 0 now, and then I'm going to measure the height of this specimen again, and I hope we are going to get the accurate value once again. So, and okay, now it's it's 1/1000th of 1 in the 1,000 of the millimeter difference when I move it to this location. Let's try to move the specimen a little bit to the side and make another measurement. Oh, the battery is dying. Okay. Okay, so I'm going to leave it in here. It's doing the reading, and I hope it's going to give me the value. I need it actually strong. Just leave it. I don't have the time to. Okay, now, yeah. So we have 1 in the 1,000 of the millimeter error in this device. Okay, so I'm going to turn off the machine now before it's going to turn off itself, and put the specimen bag in the box. Okay, and go for the other test we're going to do tomorrow. With using the same machine, we're going to take one of these specimens we have around, like for example these blocks. We have different things to measure. For example, these are elliptical shapes. So we have the one with the circle shapes, like this one, and actually it's on the CMM machine. So we're going to check the diameter of some of these holes, the thickness of this part, the width between the two teeth, and the height of the surfaces. And we are going to take 30 readings every day. So we are every session actually. We are going to have 2 sessions tomorrow. That's means we're going to take 30 readings for each measurement we're going to make, and you will multiply. So every student will going to do that. Okay, every student is going to do that until we're going to calculate the maximum amount of the readings with this device. Now, this is the CMM. Obviously, this will be a cantilever type, and we need to move the probe. This is the probe, and this is the ruby ball we were talking about yesterday. Okay, and we need to move it by hand on the x-axis, the y-axis, and you will see that these readings are going to be changed in this direction. This machine actually have multiple functions for the readings: finding the point, finding the midpoint between 2 points, the point to the center, the line-to-line distance, the circle diameter, the line length, and the spherical shape diameter. Mainly I'm going to focus on the circular because the circular is going to be the most challenging one, and I'm going to show you how we can do that by tomorrow. We are going to take as much as possible of the points for the reading of the circle diameter of these things. The problem with this machine is it doesn't consider the spherical shape diameter, and we need to do that by the manual calculation. And the third section is going to be, third test is going to be about the surface roughness device, and actually it's working. So again, to make the measurement directly, we just put the device on the surface, and that's what we can see, the flows which are circulars, and that's mainly because we did that with the milling machine. So different surfaces is going to have different surface roughness area. As you remember from this device, the old day we used to use our fingernail instead of the probe to make a comparison between any surface and this standard. So it can be a super finishing surfaces, it's going to be a rough surface finishing. Make a comparison, then we're going to check what are the surface roughness from here, and give the approximation. And just imagine some people were able to give you the accurate value. Of course, we need to do the calibration for this one, but I consider that this one is being calibrated. We just press on this button, and the probe is going to move to the inside, as you can see here. It's moving actually, but it's too slow. And when it's going to finish, actually you can see that it's sketching the flows, the tops and the bottom, until it's going to reach the end or the movement, and then it's going to stop and making the calculation. Actually we have the Gauss filter with programmed in this software, and it's going to do the calculation and give you what will be the approximate height. So the height of this stuff is going to be 2.785 micromillimeters, as you can see here in the unit. Once again, we will try to take as much as possible of the readings with this device. I'm going to do the reading actually not using the machine directly. I would like to use the software which is going to be run on this computer, and we'll try to make a report with all the data. It's going to give you all the data for the lines, top and the bottom parameters. Okay, so that's it. This will be the machine we're going to use. The surface roughness, the CFM, and the height gauge standing there. Okay, and so see you tomorrow, and I hope that you find out your way. Oh no, before I get to turn on the machine, let me take you up, because maybe you're going to lose your way while you're going up. So I'm going to go upward again. This will be the reverse trip to the place. Where did I put my card? Anyway, I need to take my glasses and my mask and leave the place. So, oh, by the way, when you come here tomorrow, you need to wear the gloves. And I advise you to bring the mask. And this will be, of course, for your safety. Leave the place. If you're going to have safety glasses, it's going to be a good advantage. Leave the place going the same direction. We came from here to the door, so we're leaving the other way, which is going to be the left side. We're walking all the way. And then we're going to have two choices. One of them is not going to be available for the student who are leaving after 5 p.m., which is going up. And this will take you to the building 1 directly. So I'm going to go through the elevator again. Okay, so leaving the same way. I've told you that this will be a good reference. The washing room, once again, the ladies' room is here, and the men's room is here. Okay, so the second exit to the right is going to be the elevators to upstairs. Okay, so that's the elevators. Just come to here, press the button, go to the main lobby, and that's it. Okay, I think that we already pressed the elevator, but I will do it again so we can go to the main
Car
lobby
D.
and go up. Now, in case of emergency, if we are going to have the fire, you can use the fire stairs, or simply you can leave that way through the garage outdoor. Okay, so that's it, and see you later.